Unit 1, Section 2. Section 1, sort of. Polynomial functions and rate of change. Which of the following functions are considered to be polynomial functions? So polynomial functions, by definition, have integer exponents. Functions have positive integer exponents. So this is a fractional exponent, so this is out. This guy is a negative exponent because 1 over x is really x to the negative 1. Sad face, he's out. X to the fourth, good. To the third, good. Regular x, no x, perfect. That's the only one. State the number of possible relative extrema or minima of that function. Confirm your answer by graph it. Okay, so this function, relative minimum or maximum, so that's like turning points, and the turning points is n minus 1. So if this graph has a highest degree of 4, I'm looking at 4 minus 1, which equals 3. So it should have a maximum of 3 turning points. So let's go graph this in our graphing calculators. So I'm going to come over here, and I'm going to go press the y equal to button, and this is where we're going to write the equation. So we're going to write x squared. Nope, x to the fourth. My bad. X caret. Where's the caret? There it is. Caret 4. Press the arrow so that it goes down. Minus x to the third minus 5x squared plus 1. And you'll notice that these, if you haven't touched your calculator since last time, you'll notice these plots are still set. We're going to go ahead and press enter here to turn them off. Okay, we don't want those on anymore because we're not using the same plots we used last time. We're going to press graph, and it looks like that. So hard to see much of anything. I'm going to go to zoom, this zoom button. And if you scroll down, you can do, like, you can create a box, you can zoom in, out, and there's a whole bunch of options here. Or you can come all the way down to the bottom here where it says 0, and that's zoom fit. And press enter. So now I can actually see my graph a little bit better. You can see it's obviously polynomial function. Still can't really see what I'm looking for, so I'm going to click on window, and so this is going to tell me essentially what window it's given the function. So I can see here this y maximum is massive, so I'm going to change my y minimum. I'm going to go like negative 100, and I'll go 500, and then I'll do a step of 100. Graph. Okay, that's a little bit better. I want to move it over, so I'm going to go back to window. I'll change my x minimum to, let's go with negative 10. I'll go positive 10. And we'll do it in steps of 1 and just see where that takes us. Oh, that's a lot better. Okay. And so now we can see where stuff is happening, and it's around the origin. So I can go ahead and move my y-axis down. I'll probably be able to see more. So instead of having y at 500, let's bring it down to 100. And we'll change that. Aha, and there I go. 1, 2, 3. I can see them clearly right there. 3 turning points. So I have a relative min, a relative max, and a relative min again. All right, state the number of possible points of inflection, so turning points, for this function. Draw a graph on Desmos and estimate their location. Note, a graph has n minus 2 points of inflection. So if n equals 4, then the inflection points is 4 minus 2, which is equal to 2. So an inflection point is basically where you switch from increasing to decreasing. I'll show you on the graph. So we'll go back here. Y equals, I'm going to go ahead and press clear because I'm not using that equation anymore. 3x to the fourth plus 5x to the third minus 17x squared minus 14x plus 6. Graph. And there's my graph. That actually worked out really nicely with my window. So an inflection point, this is really hard to show you since I can't draw on this calculator. But as it's going down from the left side, right, and then it hits that 0 mark, it starts to go up again. Now about halfway through here, let me go, I can't go on Desmos either. You know what, you know what I can do? I can take a picture, boom. And then I can open the picture and I can write on it. Okay, there we go. So this is the inflection point right here. Give me a marker. Right there. That is the point of inflection. And the reason is because I'm starting to go up, right? I'm increasing, increasing, increasing. But then the rate at which I start increasing slows down. Okay, so it's like slowly start increasing and then faster and faster and faster. This is like when we did logistic growth models, the point of maximum growth, right? And then it starts to even out again. And then I start going down the other side, right? And here I am again at another inflection point. Okay, so those are our two inflection points on the graph. Delete that and we'll go back over here. There we go, beautiful. Oh, that's the end of that section.